Of every 1,000 people who experience side effects when using anticoagulants, 134 of them result in fatality. 34% die within the year of starting dialysis, with anticoagulants being a large factor, intracranial hemorrhage, and heparin-induced necrosis. There is a multitude of side effects that are associated with the usage of anticoagulants. They are prescribed as medication for clotting disorders, stroke, heart diseases, and are administered before dialysis and surgery as well. However, it is classified as a high-risk medication as it has the potential to do harm even when it's administered clinically. What if kidney disease patients did not have to take anticoagulants before dialysis? What if there was no possibility for you to die every time you took an anticoagulant medication? What if anticoagulants did not cost a fortune just for a monthly prescription? Presenting to you our project, engineering ticks and mosquito salivary peptides into potent and uncleavable hybrid thrombin inhibitors. As a hematophagous insect, the female mosquito feeds on blood, but interestingly, the blood it consumes does not coagulate within its body. The malaria-carrying Anopheles mosquito produces anophelin, a thrombin inhibitor that halts the blood coagulation process. The hematophagous tick also produces a thrombin inhibitor, Varegin. These thrombin inhibitors function as anticoagulants. The latest research on anophelin and Varegin unveiled two unique properties that differentiated them from other anticoagulants. One, the extensive half-life of anophelin. Unlike any other thrombin inhibitor, anophelin is resistant to thrombin cleavage when bound to thrombin. This is because it binds to thrombin in the reverse orientation, with sparse interactions between the N-terminus of anophelin and thrombin exosite 1. Secondly, the higher potency of an isomer of Varegin, known as ultravaregin. Ultravaregin is one of the most potent thrombin inhibitors with a Ki of 4.4 picomolar. So we hypothesized that the anophelin ultravaregin hybrid peptides would have both an extensive half-life and higher potency. NO17 and NO18 are fragments of the N-terminus of anophelin that will confer resistance to thrombin cleavage. UVG13 and UVG14 are the fragments of the N-terminus of ultravaregin that will confer higher potency. Different combinations of anophelin fragments and ultravaregin fragments will be joined together to produce four hybrids which differ slightly in length. HAU NO1713, HAU 1714, HAU 1813, HAU 1814. The half-life of the hybrid HAU 1713 was determined by ESI mass spectrometry. In a mixture of HAU NO 1713 with thrombin, the concentration of HAU remained high after 24 hours. Due to the presence of the anophelin fragment NO17, the hybrid HAU 1713 would be resistant to thrombin cleavage, and it has an estimated half-life of 62 hours. The potency of the hybrids HAU 1713, 1714, 1813, and 1814 were determined by firstly hybridizing anophelin fragments with ultravaregin fragments, purifying the hybrid peptides, and lastly conducting a chromogenic assay. A hybrid NC-NC termini arrangement of the anophelin fragment and the ultravaregin fragment will not work, as the N-terminus of the anophelin fragment will be distant from the thrombin exosite 1. Such a peptide will be readily cleaved by thrombin. A hybrid CN-NC termini arrangement is necessary for the N-terminus of the anophelin fragment to bind to thrombin exosite 1, and the N-terminus of the ultravaregin fragment to bind to the thrombin active site. Therefore, NO17, 18, 13, 14 are artificially synthesized with an additional cysteine residue at their N-termini. The issue is that presence of cysteine residues allows dimerization. NO dimers and UEG dimers are formed as side products, and therefore they affect the purity of our product. Therefore, our hybrid peptides need to be isolated and purified. Following each hybridization experiment, the desired hybrid peptides were purified through high-performance liquid chromatography and ESI mass spectrometry. In this chromatogram, the third peak corresponded to the theoretical molecular mass of the hybrid HAU 1713. For the chromogenic assay on the purified hybrids, a chromogenic substrate for thrombin known as S2238 was used. In the positive control without the thrombin inhibitor, a higher level of fluorescence was observed. In contrast to the addition of the hybrid thrombin inhibitor, there was a reduced level of fluorescence. For a mixture of thrombin S2238 and the hybrid thrombin inhibitor, a higher concentration of the hybrid thrombin inhibitor will lower fluorescent values. As you can see in our graph, there was a reduced fluorescent level for the 100 micromolar sample as compared to the 3 nanomolar sample and the control with no hybrid thrombin inhibitor. Taking percent thrombin inhibition as the change in fluorescence relative to the positive control, the IC50 values of the four hybrids were found to be within nanomolar range. HAU1713, having the smallest IC50 value, was determined as the most potent. By using the Morrison equation for tight binding inhibitors, the Ki values of the four hybrids were found to be within picomolar range. HAU1713, having the smallest Ki value, was the most potent again. Having a higher potency and a more extensive half-life, the applications of HAU1713 and other hybrids as anticoagulants would be highly beneficial in the medical context. The more extensive half-life of tick mosquito hybrid anticoagulants reduces the need for its constant replenishment. The higher potency also lowers the amount required for application during coatings. This is cost-effective for hospitals and laboratories. Also, given that these hybrids are mass reproducible via gene cloning, the hybrids also have a faster, quicker, and stronger anticoagulant properties. They will be especially useful as immobilized anticoagulant coatings on medical apparatus. During intravenous treatments, patients could be less reliant on consuming anticoagulants which circulate in the bloodstream, mitigating its potential side effects. As thrombin in the blood will bind to the anticoagulant coating, the loss of thrombin in the patients could be compensated by vitamin D supplementation or fluid flow to unbind thrombin and return it back to the patient's bloodstream. In summary, the tick mosquito hybrid anticoagulants are modifiable, applicable for antithrombotic coating, precursors to potent and uncleavable anticoagulants, and beneficial in the medical industry. The next steps on the research of tick mosquito hybrid anticoagulants will be to conduct a blood coagulant assay to confirm its safety and efficacy in the human body, as well as to explore bioconjugation methods such as oxime chemistry for antithrombotic coating. It will also act as a predecessor to future research. These are our references. With this inhibitor, we are not offering you a project. It's a precursor to a new generation of anticoagulants with the hope that one day it will bring a positive change to the community that we live in.